for variable name. Yeah. So let's just run this sample program and see, all right, because it's more fun seeing it executed dynamically. Let's just create a new file and create a new shell, shall we? All right, I will just paste it in. Now, as we discussed earlier on, uh, we know that DEF, the definition of a function, ends with a colon, and it requires indentation. Clearly, we can check with our original file, but we know that this has to be indented. But then moving on, we have cleared and rectified all the indentation problems, but Spider still flags this undefined name y. Did you see that over here? Yeah. Why is that so? I thought we did say y equals to 9 here. But wait, Python knows that your y equals to 9 is local. That's what we call local within the function. Local to the function. Local to the function means the scope is locally defined. The scope. What do you mean by scope? Where can we access the value of y, right? The ability to access the value of y, the scope of y exists only within the function. So here we say return whatever value is in y. That's clear because there's only one y. All right, it's very clear. And when we do that, the value 9 is being returned. Value, not the y container, but the value number 9, which can exist on its own independently of y. So the value number 9 is being returned. And after this line, because it's the end of the statement block for function, the whole variable called y is being destroyed. Nobody can refer to it. That is the reason why when we do this, Python says what y? I don't know what is y, right? Okay, so same thing goes for class. Remember, class is another keyword that starts off another new namespace and a new scope of reference. So when we define a C here, and we say, what's the value of C? Python says, what C? I don't know what is C. This C is local to the class called myClass. And therefore, it is not accessible as a global C, like as if we had written something like C equals to 123 outside in the global namespace. All right. So the global namespace has empty string, no name, and we don't have to prepend that empty string to it or whatever. We just say X. That would do. So let's run it and see, no matter what, whether there's red flag or not. It is not a good thing whenever Spider says there's a red flag. We should rectify it. But here we are just demonstrating what we'll see. So we see that x equals to 3. That's clear. And we ask, what is x? We got a 3. That's simple. What is the value of v? V activates Python to access the class called myClass, and a class basically is the design of an object. To put it simply, it's the beginning of talking about what is object-oriented programming, a really huge subject that deserves its own session or multiple sessions. So here we're not going to talk much about what's object and class. Suffice to say that the design of this object called myClass has this permanent fixture inside, this variable inside, called C. And in addition, not only that we have this container inside labeled C, this container is also not empty. It has this value and a very specific value called 123. So when we have this and we run myClass with a function bracket, it tells Python to not run this function, but create an object following the design template of myClass. Think of it as a cookie cutter that cuts into a flat dough. I want this cookie that looks like this shape. And you can do that many times, right? So myClass creates this memory object that has this design. What design? That internally it has one container, it's labeled C, and it has a fixed value called 123. Then we say, what is V? V is this object called myClass, sitting in the global namespace. And our global namespace is called __main__, which is always the name that is going to be attached to the global namespace. All right, because referencing a namespace, you have to have a non-empty string. Python basically has decided that this fixed name will be always the global namespace name. All right, but when we refer to it, it is like empty string. So referencing it programmatically is empty string. Internal memory referencing is via this fixed underscore underscore main underscore underscore. Next, what is the value of W? At this point, Python runs the function, goes inside the function, defines the local variable y that is invisible to people outside, all right, but it's visible to all the statements inside the function. And when we say return y, it returns 9, discarding the container called y right after this. So there are two things. Y, the container called y, containing this value called 9. Return, that statement, takes out this 9 and throws it back to the caller and destroys permanently this container called y, right? So the 9 is being caught and then held into this container called w, so that when we print it out, it is okay, it says 9. But when we say what is the value of the y, no way, we can't do that, all right? So you cannot dip into it. Python recognizes it as actually my function dot y, but you cannot refer to it because function is a runtime mechanism. It comes alive only when you run it. But my class is an object, so long as it has been created, that object is there all the time. All right, so we could say what is v. We could also say, you know what? I know v is designed like a my class, and I know my class because I designed it, right? And I've defined my class to have a container called C. Can I look at the value in the container called C inside this object called contained by V? And the answer is yes. So if you say C itself is not good, it's like calling John with two Johns in the space. You have to say Watson John, and that particular John, then the right person, the uniquely named person, will respond. Same thing here, right? Now you might be wondering, what if two namespace clash? Python will ensure that there will be no such thing happening. All right, so it cannot allow any namespaces to have the same name. So that part is ensured by Python. Therefore, the only thing that we need to do is to make sure we are clear what we are referring to. Okay, now if we say that y equals to 88 and c equals to 77, all right, if we run this, what will happen? Let's look at y. If we run this, first of all, there seems to be a clash, but actually there's no clash because the outer y has got a full namespace. It's like the full name called Smith John, right? So the outer y is called underscore underscore main underscore underscore dot y, referencing y's internally, and it's got this value 88, and it's there, right? Internally, when we run the function y, that's a local variable. So in some sense, to Python, it's quickly created as my function.y, stored with a 9, and doesn't clash. All right, doesn't clash. And then when we return, it picks out the my function.y, that 9 value, not the 88 value, and returns and then destroys my function.y. So no problem at all. Likewise, if we print what is C, all right, if we print what is C, we'll get 77, that's right. But when we print v.c, then we'll get what we see here, 1, 2, 3. So let's run this. Okay, good. So we get 88. This is not overwritten by y equals to 9 in any way, because now we understand it fully, because the original y is the main.y, right? Okay, the full name is called main.y. This y, if you like it, you can imagine it to be called myfunction.y. But we cannot type myfunction.y to access it because it's created dynamically. So at static time like this, when we ask what is myfunction.y, there's no such thing. You cannot do it, right? But my class is okay because it's a memory object. Once it's created, it is fixed there. You can sort of dip into it and inspect what is inside. That's fine. So that's the difference between function and object. So can we print C? Yes, and it accesses this C without any qualification. We called John, and then this is global.john, right? So it's main.c, and the value 77 is printed. What if we want to access Watson.john, the my class.c? So we can say v.c. Sorry. Yeah, it's got some problem with the shell when I run it repeatedly. So let's run it again. So here we can say what is v.c. It's correct. In fact, we can say my class, that template has got a permanent value, right? And it is 123, isn't it? Yeah, you can also do that. You can dip into that object to look at it. You can dip into that class to look at it also. Okay. All right, so that is, let's come back to our slide here. That's for statement block and scope. Okay, do you have any questions? If you have any questions, put in the comment. YouTube sends me a notice and I will try my best to respond to you in the comments as well.